Good day everyone, the problem solver is back, and today we are going to talk about a real example of a coding interview in one of the big companies. And the problem today is called the maximum subarray. You can find this problem as usual on LeetCode under name maximum subarray. You can find this problem there, you can practice on your own after the video. So what is the problem now? So the problem here, it is saying that you have an input of integer numbers, something like this. Input number, you have an array. And the array contains some numbers, integer numbers, could be like this, 2 and 3, minus 1 and 2. And your task here is to get the maximum subarray of this array. So the maximum here is, we have 2 and 3, so we have summation of both elements to 5, then we have minus 1, so still 5 is the maximum, and then we have 2. 2 will be the maximum subarray of this example is 6. And the subarray in that example is the whole array. So how can we solve this problem? So the brute force solution here is relatively easy. We can try out all the possibilities of all subarrays of my array, and we get the maximum subarray of those subarrays. So how can we do it? So the first one, we can start with 2. So we can imagine that we have 2 iterations, we generate all subarrays, and depends on the summation of each subarray, we can see what is the maximum subarray we have. So the first one is 2. In first iteration, we try out with 2. So we have 2. So the maximum now is 2, like this. We have only one element. Then we try out 2 and 3. We try out 2, 3, minus 1. Then we try out 2, 3, minus 1 and 2. And we get all subarrays of this. Then in the next iteration, we try out 3. Then 3 and minus 1. 3, minus 1 and 2. We generate all the subarrays and we check the maximum summation for each subarray, and based on that we can find the maximum subarray. Then we have minus 1, minus 1 and 2. Then the last one is 2. Check it only, and this we can generate the whole subarrays. So let's try to code based on the brute force solution, and then we can check how can we optimize this. I will start coding here using my Visual Code Studio, and let's try to find a solution using the brute force one. So first thing, we have to check my input, if my input is we have an array or not, and based on that we can continue. So if nums equal null, or nums.length equal 0, it means if we have an array and if we have elements in this array or not. So if we don't have an array, or the length of this array is 0, then we can return 0. And also you can check with your interviewer, should we throw exception in that case, or we basically return 0. Then we can start, we should have integer maximum that will hold the maximum we can find until we find the maximum one. So we can start by initializing the maximum variable with one of the elements, because in that example the numbers could be minus, it could be negative numbers or positive numbers. So 0, initializing the maximum with 0 is not a good choice for your case. So we will initialize the maximum with the first element in the array. Then basically we can have two inner loops inside each other, and we get all the subarrays. We check the maximum of each subarray and we return the result. We have two iterations, and based on these iterations we can generate all the subarrays. So the first one would be for int I equals 0 less than numbers dot length, and the second one will be for int j equal I and j less than numbers dot length. And we are starting the inner loop from I because we don't want to start from the beginning each time. So we start in our example, if we started from the first element, so we continue to the end. If we started from the second element, we can't start from the first element. So the start from the second element and we continue in my array until the end. So we start every time from I, not from 0. And we can initialize integer current max equal 0. We initialize current max equals 0, and here current max plus equal numbers of j. So every time we go and we sum the current element with my current maximum, and here we can check if current max greater than max, we can make it max equal current max. And after the second loop, after iterating over the whole array twice, we can return max. And basically this is the brute force solution. We iterate over the array twice and we generate all the possibilities of my array, all the subarrays of my array, and we sum this subarray and we return the maximum subarray based on this. So we talked about and we coded the brute force solution, but can we do better? Can we have a better solution for this? The big O notation for this case is big O of n square. It's big O of n square. And maybe we can find a good solution with a less complexity, less than O of n square. So here we can try out one of the algorithms called dynamic programming, and basically we can use memoization technique to save the current subarray, the current sum of subarray we are going to. And basically we can do that in one iteration. Let me try out with you how we can solve it. So we have array in our example. We have array, we start from 2, next element 3, -1, and last one is 2. And we can iterate over the array once. And basically we should have, in memoization, we have another array that will hold the maximum subarray we can have. Until the current iteration. So we start with 2, so the maximum we can find starting from 2 is 2. Then we can start with 3. 3, either 3. So in the second element here, we have two possibilities. Either we start from 3, or we start from the current element, or we continue on the previous one, on the previous subarray. So how can we decide this if the summation of the current element plus what we could sum so far from previous is greater than the current element, or we start from the current element? So we can decide based here if 3 plus 2 from my dynamic programming, my DP array, and this is nums. Excuse me for my drawing, is very bad drawing, but basically we can decide if the summation of those two elements is greater than this current element or not. Based on that, we can find, based on those two cases, either we start from the current element or we continue on the previous summation of the previous elements. So 2 plus 3 here is 5, and it is greater than 3, so basically we can continue in our array. So we started from 2 and we continue 3, and then we have minus 1. So the cursor here is on minus 1. Is minus 1 is greater than minus 1 plus 5? Yes, 4 is greater than minus 5, so we continue on this. Then the last one is 2 greater than 2 plus 4? No, so 2 plus 4 is greater, so we have 6, and our maximum subarray in that case will be 6. So let's jump and code this based on dynamic programming memoization technique. I'm going to delete the code so far that we created. I will keep the first condition to continue. We check if the array is null or the length is 0, we return. Otherwise, we can have our dynamic programming array. New end of numbers.length. Then we initialize the first element in the dynamic programming with the first element in the numbers array. So dp of 0 equal dp of equal nums of 0, and we loop over the array starting from the first element. Then I++. So the current dp of I, as we said, it's either to be the current element that we have or the current element plus what we could sum so far. So it is math.maximum of numbers of I, or numbers of I plus dp of I minus 1. So we have now the dp of I will hold the maximum one, and also we can check here the maximum. So we have maximum, we didn't define maximum, so if we have int max equal numbers of I as well, so we can make max equal math.max and dp of I. So we don't have to loop again over the dp array to check what is the maximum. We can hold it as we continue, and then we return max. So basically this is a kind of dynamic programming problem. Here we could solve it with memorization, and we can loop over the array once, and while we are going we can save the current maximum subarray, and we don't have to go through the array a couple of times. I hope you enjoyed my video today. I want you to hit like, share, subscribe for my videos, and please write me comments for your solutions. Write me comments for like any future problems that you want me to solve for you. And keep it up, guys, and happy coding, everyone. And see you next video. Bye.